Hi everyone, we are from Group 3 SKTK 4153 class in Universiti Teknologi Malaysia. Today, we would like to present about Heuristic 2 and 3 for process design. Before that, let me explain about what is heuristic. Heuristic is straightforward rule of thumb that is developed based on past experiences.
For Heuristic 2, it says that we should use an excess of one chemical reactant in a reaction operation to completely consume a valuable toxic or hazardous chemical reactant. And the MSDS is used to indicate which chemicals are toxic and hazardous.
In this distribution, decisions are made concerning the use of one chemical reactant in excess in a reaction operation. Second, the handling of inert species that enter in the feed streams. And third, the handling of undesired byproduct generated inside reaction. Let's take a look to our previous case study, which is ammonia production. In this process we use nitrogen and hydrogen as raw materials to produce ammonia. However, in the product stream there are presence of nitrogen and hydrogen.
Then the hydrogen and nitrogen were separated from ammonia using condenser. Supposed hydrogen and nitrogen can be released to the air, but hydrogen is an explosion hazard. So to eliminate this risk we apply Heuristic 2. And used excess nitrogen in raw material to ensure the hydrogen is fully consumed. We decided to use nitrogen as excess material instead of hydrogen because the price is much lower. Then we recycle back nitrogen into the inlet stream to improve the efficiency of production.
Hi there. I am Shiva. And I will explain on Heuristic 3. It is stated as: when nearly pure products are required, eliminate inert species before the reaction operations. When the separations are easily accomplished, and when the catalyst is adversely affected by the inert species. Which means that the inert species must be removed before the reaction, as it won't harm the catalyst during the reaction. And also when the separations of the inert species are easy to do. But do not do this when a large exothermic heat of reaction must be removed. Because the presence of inert species will absorb some of the heat generated, thereby lowering the outlet temperature of the reactor. Moving on. Once we decided to remove the inert species, now, we must make sure if we want to remove it before the reaction, or after the reaction. And for that, we have to consider several aspects such as, the physical properties of the substances. The ease and cost of the separations must also be assessed. The list of the several aspects that we can count in when separating the inert species are: if there is differences in relative volatilities, distillations are used. If there is differences in freezing points, crystallization are used. If it is related to permeabilities for pure species, dense membrane separation are used. Size of the reactors and separators are also must be considered. And the use of simulation are being implied as well. Hello everyone. I am Jordaens. We now will see an example of Heuristic 3. In this case, it is desired to produce methyl tertiary butyl ether in a refinery plant. As we can see on the reaction on the left, isobutene is needed. However, isobutene is available in mixed stream together with 1-butene and 1,3-butadiene as in the picture on the right. And the question is it preferable to extract only isobutene for this reaction? Let's see how it is being done. First, it is satisfactory to examine its vapor pressures of all the components. A graph of vapor pressures of the components against temperature is plotted using Aspen Plus software, as in the picture on the right. And to respect to methyl tertiary butyl ether, at 200 Fahrenheit, the relative volatility has been calculated using the formula on the left. And we can see that the volatility of 1-butene and 1,3-butadiene differs significantly from isobutene. Hence it can be separated by distillation process. Do not forget about other considerations too, such as the impact on the catalyst, volume of the reactors and distillation towers, and the temperature levels in the exothermic reactors, must also be considered when making the decision.
That is all from us. Thank you everyone.